I'm going to use the project, which has been a Mimic project for you during the learning process for this particular task set, as an example of how you go about data modeling. Now, data modeling is a very, very high value system within the marketing scheme, and is representing a really, really straightforward task. If you do it properly and do it logically, you will understand that you will get good credit for it, and it will give you good marks. So here's the situation, and broadly, what we're going to do is we're going to say that imagine that you were modeling this component of your website, the gaming sales component. So you look at the brief that you've been given, and the first step that you would do in this particular process is identification of the things you want to include in your database. Now, these things we call entities. And an entity is a concept that you can represent under a single name or phrase. If I said the word vehicle to you, I think all of you would instantly get a concept in your head that says vehicle. I know what that is. It's something that moves from A to B, and it's something that may transport cargo or persons and so forth. But you all got your own ideas about what a vehicle will be. And that's what the first step is that we have to do with our modeling process for the database. What I'm going to do is I'm just going to set a space up here so that I can just make a note on the screen here for us to act as a memory point. This is about the sale of games, isn't it? This is about the sale. This component of your website is about the sale of games. So I think the one thing we want to model is a game. Yeah, so that's an absolute candidate. We call them entity candidates, and that's an absolute candidate for a thing that you would model in your database. There's a sale. Now, a sale is likely something that you'd want to record every time a new game is sold, a new sale is made. Whom do we make our sales? We make our sales to customers. And notice that I'm using the singular of all of these as we go through, and that's the convention, and it's the best way to approach this because of the reasons I gave you when I explained this in the class. So we're going to have a customer. Is there anything else that we might want to model in our database? I think that's the basis of our database, but maybe we can carry on a little bit. So maybe the game is of a type of a genre. That kind of makes sense, doesn't it? And maybe a game has a publisher. Does that make sense? I hope it does make sense to you. And maybe a customer has an address. Now, this is a slightly dubious one, really, isn't it? Because most of it's going to be electronically shipped in terms of delivery these days. You wouldn't send out a Blu-ray disc or a DVD or anything in it is. But let's just use it as a convenience for me in this task. So I now have 6 candidates which I'm going to model as entities. And what we do is we go through our process of modeling in steps and stages. Let's talk about the process of data modeling. And as I said, it's a logical process and it's a step-by-step process. And you build from very conceptual components where you're just thinking about ideas and topics into very detailed descriptions of what will actually be made in a database system of your choice. So the first step is at the modeling stage where we identify the types of models we're going to use. The conceptual model is one that I'll explain in just a minute. The logical model, physical model, and then the entity relationship diagram, or ERD. These are the usual models which are created in a well-defined database system. The conceptual model defines the entities, only the entities, and the idea might be game and genre, and defines the relationship between them. That's what the conceptual model is for. And at this stage, it's very easy to change things. There's no cost involved, no programming has been done, no database has been implemented, no resources are being used in a cloud database. At this stage, it's just ideas, and this is where you make your changes, not when you've made the whole database system, and then have to reverse engineer it back out, find yourself a solution to a mess you've made. So the conceptual model is really important, and you arrive at the ideas, And the team would work on the conceptual model, and the team would establish a structure that they're going to create. The logical model takes the thing further. For each of the entities, it's going to define what are called the attributes of that entity. For example, if I was doing a vehicle and I wanted to say number of wheels, that would be an attribute of a vehicle, wouldn't it? That describes that vehicle, and an attribute is something that describes the characteristic of something or a property that it possesses. Then the next stage after the logical model is going to be the physical model. Now, the physical model defines how each attribute will be created. This is very important in the particular database being used. Now, database theory says relational database theory is universal, and that's true. However, there are various implementations of relational database systems: Oracle, SQL Server, MySQL, all those MySQL, and those sorts of things. So there are many ways in which you can make it. And the way in which implementation of attributes is used in each different system can mean that you have to define a particular data type, for example, for each different type of system, because an int in one system may be bigger than an int in another system. So we make sure that the physical model is going to be describing what data types are going to be used. And this is the important one for us, really. Because when we get to the process of modeling these in Django, you have to say for your model what type of data is going to be used in each of the attributes that you're going to include in your database. And this is where the main thing will be created. It's also probably a good source for the data dictionary. But there's one final model that we should think about, and that's the entity relationship diagram. Now, the entity relationship diagram is the most complex of them all because it's leading up to this stage, and it includes everything that's gone before it, but it fully describes the database to be implemented. What I mean by that, it includes any constraints, for example, size limits that you may want to put on a field such as a forename. You don't want to put a system of storage larger than it needs to be. Imagine that you said forename can be a maximum of 50 characters. That would be a constraint that you would include in the ERD. And it includes definitions of cardinality. So that means that one to many. So one genre can have many games, and you define that in your ERD. And it also can be used in some software systems to produce scripts. So there are various ways in which you can do that. Most of them cost money, and most of them cost quite a lot of money, actually. But the system that you can do this is once you've created your diagrams and you've got to the ERD, building up from the conceptual through the logical into the physical and then into the ERD, you press a button and it produces a SQL script that you can run as a query inside a database system, and that will create all of the tables for you. Now, in Django, it's slightly different because the Django system is about models being migrated into the database, SQLite 3, but it's slightly different in our case. But you should know about the entity relationship diagram, and you'll gain good credit if you produce one. It's seen as being the most professional and complete of all the models. Having talked about the models and identified our entities, let's now move on to the actual process of modeling.